Welcome, dear students. We are using some techniques to solve some problems related to forces and resultant of forces. Here is a problem, and in this problem, you are asked four coplanar forces acts on a body at a point O, as shown in the figure. Find the resultant force. If you look at this, is a type of interesting type of example where he is trying to check your previous knowledge. Question is, there are two forces. One is F1, 80 Newton, F2, 100 Newton, F3, that is 110, and F4 is 160 Newton. And these are the angles at which the forces are acting. So the angle first one is along force one is acting at angle 0, and other one is acting at 45 degree, third one is acting at 30 degree, and the fourth one is acting at 20 degrees. So here are the forces 1, 2, and 3, and here is the fourth force. These all forces are acting at the point origin O. This is the O point at which these are acting. So you are asked to calculate the resultant of their forces. Then what you have to do? Sequentially, you have to move here. First, you will calculate horizontal component of force F1. Then you will calculate F2x. Then you will calculate F3x, F2x, as you have seen the value of the angle, and for one F1x value of the angle, then similarly F2y, and you have placed the for y you use sine theta, for x you use cosine theta. After putting you have calculated horizontal and vertical component of this. Similarly, we will resolve for F3, and it will be F3 cos theta 3, F3x, then you will go up to F3y. You have calculated F3, and then you will move up to F4x and then F4y. And here, like this, you have resolved this force into its component. If this is a force F2, then it is F2x, the horizontal component, and F2y, the vertical component. Same is applied for the other forces, types of the forces as well, to find the horizontal and vertical component of the forces. Now you have calculated horizontal component of force 3. Again, you see this is the concept. So you have calculated F3x, this is F3, and in second quadrant, this is first and this one is second. In second quadrant, the value of x is negative, so that's why it is taken as negative. And in third quadrant, both x and y will be negative. But in fourth, x will be positive and y will be negative. So here is the fourth. So if you look at 160 is the fourth, and this is the cos theta between the two, and we have calculated f4x. Similarly, we calculate f4y. We are taking negative sign. These are the coordinates, because in third quadrant, the value, how you have decided the value of the angle where it lies, you have decided that this is the coordinate of the force. So if you look at, you are adding all components of x component of the force, f1x, f2x, f3x, and f4x. You have added, and you got fx. Similarly, you are adding all y component of the forces which you have calculated. And after calculating y component of the forces, you got y component. And here it is fx and here is fy. From where you have calculated fx, you have calculated fx by using these techniques, but you have to keep in your mind the coordinate. The first coordinate, if the angle is between 45, that is x and y, both are positive. But if you move to the other side, y will be positive, x will be negative. But if you need third, move in third coordinate, depending on the value of angle, that is 20 degree force is 160, and the angle is 20 degree, 20 not 120. Where is the value of the force? Yes, 20 degree. And if you look at where is the value of the force, Here it is. And after putting the values, you have calculated horizontal and vertical components of the both. All horizontal components and all vertical components. You will add these two, you will be getting fx minus y. And how to calculate magnitude and resultant, this is the formula fx square plus y square. After putting values, this is the resultant force, magnitude of the force. If you are asked to find the angle or the direction of this force, this will be the formula, that is Fy or Fx. You have already calculated four vertical component of the forces, and similarly you have calculated four horizontal component of the forces, and it is in the form of Fx and Fy. You will put the value of Fy and Fx, you will be getting the value of the angle. And if you see what will be the direction, subtract this angle from 180 degree, you will be getting the exact value of the orientation of the force, uh, in which direction it is. But it shows Fx is negative and phi is positive, so the resultant force lies in second coordinate. Now where you learned with the value of the angle sine coordinate makes an angle of 38 degree with negative x-axis. So the angle between F positive x-axis and anti-clockwise direction is this one. 180 minus 36.8, this will be the value of the angle. And with this, it was very easy to understand. If there are nth number of forces, then first you will resolve all forces into its horizontal component. Then you resolve it into vertical component. You will add all types of horizontal component by using the angles, and you will add all the vertical components of the forces by using the angle. And finally, you will find the direction, that is angle, as well as magnitude of the force by using the all. Thank you.